I will talk about economies of scale in a logistics context, and I will also talk about the best operating level of a factory. Economies of scale is an extremely important concept from microeconomy. So, when we look at the cost of producing things, the most basic cost function always has two components. On the one hand, we have costs that are independent of our output level. These costs occur independent of the volume of the quantity we produce. And on the other hand, we have costs that directly depend on the output level. So let's say we build a big container terminal, and we can use this container terminal and all the equipment that we buy to operate this terminal. We can use this for 20 years. So if we have 1,000 containers, if we have a turnover of only 1,000 containers during these 20 years, then each container creates the total cost of the terminal divided by 1,000. Of course, this will result in extremely high cost. If we can increase the number of containers we pass through this terminal, then our cost per container will go down significantly. And this is part, or this effect is called economies of scale. Economies of scale are the cost advantage that an enterprise obtains due to its scale of operations. Scale means the number, the output, the amount of output we produce. The cost per unit decreases with increasing scale. However, there's also an opposite effect, diseconomies of scale. And by diseconomies of scale, we mean the cost disadvantage from which an enterprise suffers due to its organizational size or scale of operations. The cost per unit increases with increasing scale. Let me give you an example from outside the field of logistics. Just look at our teaching at Geotech. So, a very important part of the fixed cost at Geotech are, of course, the lecture halls that Geotech needs to provide and the salaries of the professors. So this can be considered as fixed cost. Now, the more students are in my course, the lower we can create economies of scale, and the cost per student will be reduced. Yeah, the more students, the lower the cost per student at a university. However, the quality of the teaching will go down at some point. Of course, as a professor, when I teach a small group of students, like let's say 20 students only, it's really a very small group, then I have much better interaction with the students. I know the students, I know their weaknesses, I know their strengths much better, and I'm sure the learning output will be much, much higher compared to a big number of students where the professor has problems knowing all the students. He cannot discuss individually with the students. The professor cannot, in all cases, interact with the students as smoothly as this is possible for a smaller group. The flexibility is smaller because everything needs to be better organized, much more time in advance is required for the organization. The type of assessment also needs to be more standardized. You see, we have a lot of Moodle assessments that can be automatically graded. I cannot go for individual writing examples because the time to grade this would be very, very high. So you see, the more students I put into one class of a professor, there will be some point where the quality of teaching will be reduced. So this can be an example of diseconomies of scale. However, here the cost are less the monetary cost, but more the cost in terms of what is the output, how is the output, how is the quality, what is the quality of the produced output. And because of these two effects, here is a graphical, a visual representation of the effects. On the x-axis, we have the number of produced output units, and on the y-axis, we have the cost per unit. And there is some point when we produce more, when we move from left to right on the x-axis, the cost per unit will be going down. And at some point where they are minimum, this is called the best operating level. And after this point, when I increase the output, the cost per unit will be increasing. If we do not look at the educational example, but more in a manufacturing example, this might be the case when the capacity of the factory is not fully used, then we are more here on the left side. Then we increase the output in order to approach the capacity of the factory. And then at some point, maybe we need to pay overtime to our workers in order to produce more. There will be more trouble with our equipment. Because of heavy use, it might break earlier, it might require more maintenance, and the cost per unit will increase. So these economies of scale, I'm sure you will study it in much more detail in your microeconomics course. This is a really important concept that will stay with you until the end of your study program, I'm sure. Now, let's focus on this best operating level. Usually, every type of facility has its own best operating level. A small facility will have a different type of operating level, meaning a different optimal output that leads to minimal unit costs than a medium or a large facility. It's the same with geotech and the lecture rooms. We have certain lecture rooms here at geotech. We can easily accommodate 100 students, and when we go higher to, let's say, 200 students, then the number of rooms where we can put into 200 students is going down significantly. And if we have like 400 students in one course, we need to split them over several rooms. We cannot put them in one room anymore. And this would be a good time to think about a bigger lecture hall, which would be, in terms of this example, a bigger facility. Okay, depending on the facility, on the size of the facility, there might be different operational levels. So it's not always a simple decision to expand the production as far as possible, because the output, our manufacturing output, needs to correspond to a certain facility level. And this also means we cannot, or sometimes it makes no sense to gradually increase our output. So if we expand, then we need to expand by a big margin, by a big step, to get to a better capacity utilization of another bigger facility.